The third experiment in our syllabus is characteristics of various light sensors, LDR, photodiode and phototransistor. The objective of this experiment is to understand the lighting sensors by the basic principles and focusing on the working mechanisms of LDR and a photodiode, and therefore to investigate how the resistance of an LDR and the current or voltage of a photodiode vary with the different intensities of light, and to measure and plot the static characteristics of LDR resistance versus the light intensity. So for the light intensity in our experiment will be varying the bulb voltage, and for similarly for the photodiode. And also we can compare the performance and the applications of LDR and photodiodes, highlighting their advantages, disadvantages and typical use cases. On the applications in the real world system, we can discuss the potential applications like automatic street lights, solar tracking system and the optical communication. These objectives aim is to build a strong theoretical and practical understanding of the light sensors and their role in the electronic and optical systems.
Going to see the characteristics of various light sensors, LDR and the photodiode. Here is the trainer kit. This trainer kit is used to determine the characteristics of LDR and the photodiode. So we have to give the connections. We have to ensure the connections. So there is a dotted line between T2 and T3. So this dotted line should be short circuited, that should be connected using this patch cord, and this T4 and T5 are used to measure this output voltage in terms of voltage, and here there is an input voltage which is the variable voltage which is used for this varying the light intensity of light. This variable voltage is used to measure for the intensity of light, to vary the intensity of light. By varying the intensity of the light, the dimness or the brightness of the light will be changed. Okay, here is the trainer kit. Okay, by varying the voltage or by varying this voltage or the brightness of the light, we are going to measure this. We are going to measure the output voltage, how the light and the voltage and the current are going to be determined. So to measure the output voltage and current, I am using voltmeter for measuring the voltage. From the same card, I am taking the multimeter to measure the current. Okay, now switch on the circuits. We are going to measure this, I means input voltage. By varying the intensity of light, we are going to measure this output voltage now. First I am varying this input voltage for varying the intensity of light as 4. Yeah, 4 voltage. For this output voltage is measured as 4. Now the current is measured as 2.8 microamps. Then varying the voltage to 6.5 and the output voltage is 4.5, where the intensity of current is, that intensity of light measured in current is 3.5 microamps. Then varying to 8. And the output voltage is measured as 4.6 and the light is measured as 3.6 microamps. Similarly, we can take the reading up to 10. Thank you. So we have completed this characteristics of LDR. Now we can see about the characteristics of photodiode. Okay, just we are in the same kit, we are doing the experiment. We are just replacing this content here between T2, T3 as T8 and T9, and we are replacing this T4, T5 to this T10, T11. One is from this T4 to T10, mainly we will be measuring this voltage. There is an resistance R2. The value of R2 can be measured using this multimeter. Okay, so that we can tabulate the reading for voltage, current and voltage drop across this R2. Okay. Okay, now similarly again we are going to vary this voltage. By varying this voltage we can measure the change in voltage in this output, and similarly there will be change in this resistance. Okay, this, so similarly then we are again for the next reading we can changing into 8 voltage. Then we are seeing this output, what is the output, now it is displayed as 5. Then we are taking the reading, noting the value of R2. So we can put the tabulation for bulb voltage, and the current can be calculated from this R2 and this voltage drop. Okay. Then finally similarly we can draw a graph between this VI curve, voltage in x-axis and current in the voltage in the x-axis and current in this y-axis. So the characteristic curve will be linearly increasing.